In this podcast, we're looking at atoms to find out what they're made from and why they're sometimes radioactive. So Dave, what actually is an atom?
Well, an atom is the smallest lump of an element you can have, which is still that element. They're absolutely tiny, so small that you could line up about 10 million of them in a millimetre.
So atoms are the smallest things we know of, the smallest that you can get, presumably.
Scientists originally thought that an atom was the smallest thing possible, but an atom is actually made up of even smaller particles called protons, neutrons and electrons.
Okay, so how do those constituent parts actually go together to make up an atom?
The protons and neutrons are all concentrated in the centre of an atom. They make up the nucleus, which accounts for about 99.9% of the mass of the atom. Now, the mass of an atom is absolutely tiny, so it's difficult to measure it in kilograms, but conveniently the masses of a proton and a neutron are about the same, which we often call the relative mass unit. This means that both protons and neutrons have a mass of about one relative mass unit.
And what about the electrons?
Electrons are much smaller than even protons or neutrons, so they have almost zero mass. They form a cloud around the nucleus. Electrons have a negative charge, so they're attracted to the protons, which have a positive charge. An atom will have the same number of electrons as protons, so the charges cancel out, and overall the atom is uncharged.
So do atoms always have the same numbers of electrons and protons?
If they don't, they'll be charged, and a charged atom we call an ion. When they have more electrons than protons, it will be a negatively charged ion, and if it has more protons, it will be a positively charged ion.
So does changing the number of electrons alter the type of atom that it is?
No, but changing the number of protons does. Each element or type of atom has a different number of protons. Hydrogen has 1, carbon 6, chlorine 17. If you change the proton number, you change the element you're dealing with.
And what about the neutrons?
Well, neutrons have no charge, so changing the number of them doesn't affect the overall charge. An atom with extra neutrons will interact with electrons and other atoms in an almost identical way, so we call it the same element. But as neutrons have the same mass as a proton, changing the number of neutrons will change the mass of the atom. It's easiest again to measure this in relative mass units, which will be the number of its protons plus the number of its neutrons. We call this the atom's mass number. If you have two atoms with the same number of protons but different number of neutrons, we call these isotopes of the same element.
So does this mean that you could have different isotopes of even a tiny atom like hydrogen?
Yes, all forms of hydrogen have one proton. It has a mass of 1, so on its own it would be called hydrogen 1. There are two other forms of fairly stable hydrogen. These are hydrogen 2, also called deuterium, which has 1 neutron and 1 proton and a mass number of 2. And there's hydrogen 3 or tritium with 2 neutrons and a mass number of 3.
So what's the difference between these different forms of hydrogen?
The extra neutron can make them unstable, in other words radioactive, which means they can split apart in a process called radioactive decay.
And what's that?
Radioactive decay happens when unstable isotopes release energy by giving out what we call an alpha or beta particle, or by releasing a gamma ray.
And what happens to the atom after that?
If it releases a gamma ray, then it will just lose some energy. But if it releases an alpha or beta particle, the atom itself will change. Beta particles are released when a neutron splits up into a proton and an electron, and the electron is spat out as what we call the beta particle.
So the atom will lose a neutron and gain a proton when that happens?
Yes, and because protons and neutrons have about the same mass, the mass number won't change, but the proton number will increase, and therefore the type of element will change. For example, hydrogen 3 with 2 neutrons and 1 proton will emit a beta particle to become helium 3, which has 2 protons and 1 neutron.
And what about alpha radiation?
An alpha particle is actually a rapidly moving helium nucleus made up of 2 protons and 2 neutrons, which is created by an unstable atomic nucleus splitting up.
So the atom will lose 2 protons and 2 neutrons if it undergoes alpha decay?
Yes, so its proton number will go down by 2 and its mass number will go down by 4. For example, uranium-230 with 92 protons will release an alpha particle to become thorium-226 with 90 protons. Incidentally, it was alpha particles which gave us our first glimpse of the structure of the atom. Around the beginning of the 20th century, scientists knew that atoms were made up of positive and negative parts. They thought they were all mixed together at random, a bit like a plum pudding. However, at Cambridge University, a scientist called Rutherford showed us that this couldn't be the case. He was doing an experiment which involved firing alpha particles at an incredibly thin piece of gold foil and looking at where they went. He expected they might be deflected a bit by the plums in the pudding of the atoms.
And what did he find instead?
He was shocked when some of the alpha particles came straight back at him, showing that there must be something solid enough for the alpha particle to bounce off. This meant there must be a part of the atom which had a lot of mass and charge concentrated into one place, in what we now call the nucleus. This gave us a view inside the atom and showed us that the particles couldn't be in a jumble like a plum pudding.